Hello, good morning, students. Now we'll study Haldane effect. Haldane effect is a property of hemoglobin first described by John Scott Haldane. Deoxygenation of blood increases its ability to carry carbon dioxide. This property is the Haldane effect. Conversely, oxygenated blood has a related reduced capacity for carbon dioxide. Carbaminohemoglobin. Carbon dioxide can bind to amino group, creating carbamino compounds. The amino acids are available for binding at the N-terminal and at side chains of arginine and lysine residues in hemoglobin. This forms carbaminohemoglobin. Carbaminohemoglobin is the major contributor to the Haldane effect. Histidine residues in the hemoglobin can accept protons and act as buffers. Deoxygenated hemoglobin is a better proton acceptor than the oxygenated hemoglobin. In the red blood cells, the enzyme carbonic anhydrase catalyzes the conversion of dissolved carbon dioxide to carbonic acid, which rapidly dissociates to bicarbonate ion and free proton. That is, carbon dioxide plus water forms H2CO3, which dissociates to form hydrogen ion and bicarbonate ion. The majority of carbon dioxide in the blood is in the form of bicarbonate. Only a very small amount is actually dissolved as carbon dioxide, and the remaining amount of carbon dioxide is bound to hemoglobin. So it is estimated that about 23% is in the form of carbaminohemoglobin, whereas 7% is dissolved in the plasma as carbon dioxide, whereas 70% is in the form of bicarbonate. In addition to enhancing the removal of carbon dioxide from oxygen consuming tissues, the Haldane effects promotes the dissociation of carbon dioxide from hemoglobin in the presence of oxygen. So, in the oxygen-rich capillaries of the lung, this property causes the displacement of carbon dioxide to plasma as low oxygen blood enters the alveolus and is vital for the alveolar gas exchange. So the journal equation, again it is same for Haldane effect, that is proton plus HbO2 forms H plus Hb and it releases O2. However, this reaction is confusing as it reflects primarily the Bohr's effect. The significance of this equation lies in realizing that oxygenation of hemoglobin promotes the dissociation of H ion from hemoglobin, which shifts the bicarbonate buffer equilibrium towards carbon dioxide formation. Therefore, carbon dioxide is released from the RBCs. So, clinical significance. In patients with lung diseases, lungs may not be able to increase alveolar ventilation in the face of increased amount of dissolved carbon dioxide. This partially explains the observation that some patients with emphysema might have an increased partial pressure for carbon dioxide following the administration of supplemental oxygen even if the concentration of carbon dioxide stays equal. So basic difference between the Bohr's and the Haldane effect is Bohr's effect aids in the release of oxygen from oxyhemoglobin at the metabolizing tissues, whereas the Haldane effect aids in the release of carbon dioxide from carbaminohemoglobin in the lungs. So Bohr's effect is the decrease in oxygen binding capacity of hemoglobin with increase in the concentration of carbon dioxide or decrease in pH, whereas the Haldane effect is the decrease in the carbon dioxide binding capacity of hemoglobin with rise in the concentration of oxygen. So Bohr's effect causes the binding of oxygen to hemoglobin in the lungs, right? And the Haldane effect causes the release of carbon dioxide from the blood to the alveoli.